All right, sorry about that, but since I post these on YouTube, I got to keep them all under 15 minutes, and this was going to take me more than the minute and a half I had left to be under 15 minutes. So here we go. Let's just finish this problem here. The thing is, the integral of sine squared theta requires, there's several ways of doing it, but the main one that people use is to do a trig identity, being the power reducing formula, to write this as 1 minus the cosine of 2 theta, not cosine squared, but actually the cosine of 2 theta over 2. The over 2 can come out in front here. And so I've got 9 over, there's a 2 down here, so this would be 250 times the integral of 1 minus the cos 2 theta, d theta. And so this is 9 over 250. The 1 is easy enough to integrate. That's just the theta. This one takes a u substitution with u equals 2 theta. So I end up with 1/2 the sine of 2 theta plus a constant. Now, the thing is, I've got to get back into x's. And my substitution way back here, what was my substitution? My substitution was x equals the sine, sorry, 3/5 sine theta, right? So I'm going to write it back down here. I had x equals 3/5 sine theta. And I've got a sine of 2 theta. Well, is that 2/6 sine theta? Absolutely not. No, there's a trig identity that relates the sine of 2 theta back to the sine of theta. And so that's what I gotta work on now here. So theta minus, the thing is, the sine of 2 theta, it's a half out in front here, is 2 times the sine of theta times the cosine of theta. That's the double angle formula for sine, right? Plus c. So now the 2's cancel out. And I can start doing some things here. I've got that I need a theta. So theta is, solve for theta here, 5 divided by 3. So that's the inverse sine of 5x divided by 3 minus, the 2's cancel out. The sine of theta is 5x over 3. And the cosine of theta, there's a triangle I need to draw. I need to draw a triangle where theta is the angle, and the sine of theta is 5x divided by 3, right? I multiply by 5 and I divide by 3. So the sine is 5x divided by 3. Opposite is 5x, hypotenuse is 3. The sine of theta is 5x divided by 3. Using Pythagoras now, I get the other side as 9, square that, minus that squared, 25x squared. And remember, that was the square root that we started this problem with in the previous video. So that makes me happy. And now I can see what the cosine is, because the cosine of theta is the adjacent side over the hypotenuse. So I've got a square root of 9 minus 25x squared divided by 3, all that plus c. Okay. That could be simplified, I suppose, but I think I'm happy leaving it as it is right now. Each one of these trig substitutions, you decide, because of whether you're doing an addition of 2 squares or subtraction of 2 squares, is the variable first, is the variable second, determines which of the trig substitutions you want. This looks more like a 1 minus sine squared because it's got a minus here and the variable after the minus. But it's not just a 1, it's a 9. So we build that up to there, and then we've got to make this work. Okay. You do the substitution for x, you substitute for dx, you plug it in, it gets more complicated, but then it simplifies down to something reasonable, and in this case, it took a power reducing formula to do the integral. Any way that you do the integral, you then have to get back to x's. Usually, that involves drawing a triangle. The triangle is drawn based on what your substitution was, because it's going to tell you 2 of the sides of the triangle. Pythagoras gives you the other side, and then you can use that to get all the things you needed. Like for this one, I needed to know what cos theta was, adjacent over hypotenuse.